All right, so this is fluid force on a submerged surface. And here's the question. So we have a triangular plate that's submerged in water. The surface is right on top of the plate, and we're going to determine the fluid force on that surface. So you can see up here, as a reminder, it's the formula here. So they're just adding up all of the separate forces on this object. I'm just trying to, that's what I'm trying to do. So adding up all these forces from here to here, and it's an integral. So the H is the depth. So you just measure the depth of each representative rectangle, and L is the length of the rectangles. So the first thing we're going to do is set this up. A lot of times when I set these up, I like to put the water surface as the x-axis. I'm going to try this one a little bit different. I'm going to draw the triangular surface like this. The only reason I would do that is it makes these equations of the lines, this line on the left and this line on the right, easier to calculate because you don't have that y-intercept. That's not 0. So this point would be 3, 4. Remember, this is the water level, so that's where we're measuring the depth from. And here's my representative rectangle. So all you really need to do is figure out the depth of that and the length of that and then integrate it along the entire surface. So let's start with h of y. H of y is the depth. So start from the top of the water to here. That one's easy because it would be the top value of y, which is 4, minus the bottom value, which is right here, which is y. So h of y equals 4 minus y. The length of this is, well, it's this minus this, but let's double it. Let's just do half of that. So from here to here and double it. So this length is x minus 0. X is what is defined by this line right here. So we have to figure out the equation of the line. That's easy. That's why I set this up like this. The slope of this line is up 4 over 3. So that's why I'm going to solve for x, because I want x. So the length of this from here to here is the right value of x, which is 3/4 y, minus the left value of x, which is 0. The length of the entire thing is twice that. So 2 times 3/4 y. So now we're ready to go. Just plug it into our equation. Weight density of water is 62.4 pounds per cubic foot. We have L times H, so it's 3/2 y times 4 minus y. And the only thing I haven't talked about are the limits, but the limits are just the area that the water is covering this triangular surface from. So we're starting at 0 because that's how I set my axis up, and we're ending at 4. So that is it. Type this all in a calculator. I pre-did that. I got 998.4, and that's in pounds because it's a force. And this 62.4 is pounds per cubic foot multiplied by this volume in essence. So it's 99.84 pounds. That's it.